Students, this is the reference booklet material for lessons 3.3 and 3.4. For 3.3, you're going to need a straight edge of some sort. Technically, that's a straight edge, and a compass. Let's recap these constructions. Remember, a construction is something you always do with a straight edge and a compass. A median of a triangle. A median connects vertex to a midpoint. So let's do just a quick sketch. A median connects vertex to midpoint. That's a median, vertex, midpoint. When you have two or more medians, they cross at the centroid. So to construct a median, you have to construct a midpoint of any two sides. So I'm going to construct a midpoint of this side. Pivot just past what looks like the middle. Sweep. Sweep. Take your straight edge. Line up your tick marks. There's your midpoint. Okay, you're not drawing a line here, just a tick mark because it's only a point. Now connect midpoint to the opposite vertex. That is a median. Let's do it again. Any other side, it doesn't matter which one. I'm going to do this one at the bottom. Open up your compass so it looks like it's just past what looks like the middle. Pivot, sweep. Pivot, sweep. Find your points of intersection. Tick mark the midpoint. Double hatch, it's our second midpoint, and we connect vertex to midpoint. That is a median, and they cross at a centroid. Vertex to centroid is twice as long as centroid to midpoint. And you already know this, that this is a 1 bunny hop and 2 bunny hop ratio, 2-to-1 ratio. Next page. An altitude goes from vertex to a right angle on the opposite side. Altitude starts at a vertex and hits the opposite side at a right angle. That is an altitude. Altitudes of a triangle intersect at the orthocenter. Orthocenter. So to construct an altitude, you must construct a perpendicular line from a certain point. So we're going to construct 2 altitudes here. I'm going to go from this point right here. I'm going to place my pivot on that point. I'm going to go straight across, so it's just a hair past the opposite side. This one's smiley, dimple, dimple. So smiley. And I have 2 dimples there, meaning the points of intersection. You come up, and it looks like I'm going to fly off the page. So at this point, I can choke up my compass setting, but do not change your compass setting from the 2 dimples. So keep your compass setting the same. So dimple, point of intersection, dimple. Notice I have an intersection point out here. Line it up with the vertex. That gives me a right angle. This is an altitude. All right, I'm going to do another one going this way. I'm gonna do it this way. Which one's better? Yeah, we'll go that way. Okay, again, just a hair past the opposite side, and you sweep a smiley. Whoa. My compass is moving. Let's plant that. There it is, smiley. Got it. 2 points of intersection are right here and here. Once again, my compass is going to fly off the page so I can choke it up here. Just don't change it between the dimple markings. So tilt, sweep, tilt, sweep. Line up with the vertex. Whoa, that's a bad alignment. Let's try that again. There we go. And you have a perfect right angle both sides, starting from the vertex. That's an altitude. And it's going to intersect at what is called the ortho center. The ortho center. Okay, the next one is the perpendicular bisector. A perpendicular bisector is a segment that is both perpendicular and bisects a segment. So in a triangle, let's do a quick sketch. This is the only one that does not involve the vertex because I'm focusing here on this segment. I'm going to go through the midpoint of the segment at a right angle. Notice it doesn't connect to the vertex. The 3 perpendicular bisectors intersect at the circumcenter. Circum means around. You'll see why in just a moment. So you've already done this construction. It's the same construction as the midpoint. So you choose any 2 sides, and we're going to open up the compass just past what looks like the middle of a segment. So just past what looks like the middle. Plant your pivot. Sweep an arc. Sweep an arc. Once again, some of you might find it easier just to twirl the paper. I'll demo that. And you find your points of intersection, but in this time, instead of a tick mark, you're going to actually draw a line. Right angle, hatch marks, perpendicular, bisector. Let's do another one. Do this side. So once again, just past what looks like the middle. Sweep. Other side. Sweep. Line up your points of intersection. I have one here, one here. You're going to have to keep track of that when the arcs are overlapping. Perpendicular, bisector. That would make this the circumcenter. Circumcenter. And to test this, this is really fun. I want you to do this. And again, it might be easier to twirl the paper. So I'm going to unhitch this here. You plant your pivot on the circumcenter and then the drawing point on any point of the triangle. Try to get it right on. And then hold your pivot and twirl your paper. Whee! All the way around. All the way around. I'm going to draw it. I'm going to go twice just so it's nice and dark. And if you've done this correctly, you're going to hit all 3 corners right on. So I'm good there, good there. I'm just a hair off up here. But if you did it correctly, that is what's called the circumcenter. Circum means around. We circumscribed a circle around a triangle. Circumscribe means to draw around. In center. My personal favorite. This is an angle bisector, cuts the corners in half. So just as a quick sketch, I have a triangle here. I'm going to cut this corner in half, bisect. Now, you're bisecting the angle, not the side. So this point right here is not a midpoint, unless it's an equilateral triangle. The three angle bisectors intersect at the in center. Emphasize in. There's a reason why it's called the in center. To bisect an angle, it's a smiley dimple dimple. So it doesn't matter where you open up your compass, choose any corner. I'm going to do this one. Smiley, dimple, dimple, smiley, dimple, dimple. This is an angle bisector. So we're bisecting an angle. Angle bisector. And so here again, smiley, dimple, dimple. So I'm going to choose this one over here and smiley. And again, some of you might find it easier to twirl the paper. That's fine. And my two dimples are right here and here. So smiley, dimple, dimple. Keep track of your intersections. You're going to have things overlapping. So my dimple is right there, my point of intersection. That is an angle bisector, sweep double hatch, and that would make this the in center. Now, just like the circumcenter involved a circle and a triangle, so does an in center. And so put your pivot on that in center. And you want to make the drawing point to be straight down on the side. So I'm choking mine up here. Okay, so so the drawing point is here. Excuse me, the pivot point's here, and the drawing point is straight, physically straight down, touching the side. Pick it up, and I'm going to twirl the paper again. Ooh, I think I got this done. Yep, very nice. And if you've done this correctly, you're going to have a circle perfectly inscribed. It means drawn inside. And it's going to be tangent or touching all three sides right on the side exactly. So we have inscribed. Oh, keep in mind that this point here and this point here is not a midpoint. Not a midpoint. I want you to make sure you write that down. Those are not midpoints. These are angle bisectors. That's 3.3. 3.4. So when you connect two midpoints of a triangle, you get what's called the mid segment. And that mid segment has two qualities. Just trace it, trace, and the third side. When we say third side, it's the side that's not involved. Just trace. And you should be able to feel that, one, it is parallel. And two, this is a one bunny hop, two bunny hop scenario. It is half of the third side. Now for 3.4, we were talking about math has meaning. math has meaning on a coordinate plane. So coordinate proofs are describe the qualities of shape on a coordinate, that should be coordinate plane using midpoint, slope, and distance. So we describe using midpoint, slope, and distance. We're going to do a quick example of what that is. If I want to compare segment lengths, underline the word length there. You use the distance equation, which there's your template for distance. If I want to compare the tilt of a line, tilt, such as parallel or perpendicular, we use the slope. Remember, for parallel, that's going to be slope equals slope, perpendicular slope times slope equals -1. The slope equation, y minus y over x minus x. Rise over run. Rise, subtract the y's. Run, subtract the x's. If I want to show the middle of a segment or bisect a segment, we use the midpoint equation. The midpoint equation is add the x's, divide by 2, add the y's, divide by 2. Let's see what this looks like in action. If I want to compare segment lengths, I use the distance equation. So we are given here points A, B, C, and D. And each point has a name and a location. We want to show that the segment length AB is the same length as DC. In other words, I want to show this, that AB is congruent to CD or DC, however it's, okay. Now, you can't just trace it and say, looks equal, therefore it's equal. We're trying to prove mathematically. And we can prove that these are congruent, AB and CD are congruent in length using the distance equation. Let's do that together. Notice I'm going to connect. This is x to x, so x to x. Y to y, x to x. I want to see those lines, x to x, y to y. I want to see those connections, please. -3 minus 3, that's -6. We're squaring that. And it's -2, squaring that. Okay, CD, that is x to x, y to y, oops, it's a -3 there. That's important. So that becomes double negative, becomes a positive. So again, we're back to 2 squared. All right. So here, if I was to do math meaning punchline, I can say that the math that AB equals √40 and CD equals √40. So meaning AB, CD are the same length Therefore, those three little dots are an abbreviation for therefore. You'll use it a lot in science. Therefore, AB is congruent to CD. Math, meaning punchline. We'll do two more. We're going to compare the tilt of a line, such as parallel and perpendicular, using the slope equation. Slope equals slope gets us parallel lines. Slope times slope equals -1 gets us perpendicular lines. Given the same set of points, we're going to show that AB and AD, just trace it, AB and AD, AB, AD are perpendicular. Now, once again, you can't just trace it and say, looks like a right angle, must be a right angle. You must show it mathematically. So we're going to start by finding the slope. So I'm going to set up my templates. It's y minus y over x minus x. So AB, y minus y, x minus x. Now we're going to do A to D, y minus y. That's a -3 there. X minus x. That's +3 on the top. Double negative makes a positive, but that's negative there, so that's -1. Taking a look here, you can see that 1/3 times -3 over 1 equals -1. So math meaning punchline. Here's the math. -3 over 1. Meaning, so slope times slope equals -1. Therefore, punchline AB, the segment, is perpendicular to AD. Math, meaning punchline. One more. If I want to show that something is the middle of a segment, we use the midpoint equation, which is add the x's, divide by 2, add the y's, divide by 2. Given the same set of points, we're going to show that the diagonals AC, so these you have to draw in the diagonals, AC. And the diagonal DB. Bisect each other. Bisect means they're going to go through each other's midpoint, but you have to demonstrate that mathematically. Let's get our midpoint. Add the x's, divide by 2, add the y's, divide by 2. Add the x's, divide by 2, add the y's, divide by 2. Those are your templates. I'm going to do AC first. I'm going to circle my x's. That's -3 and 4. Box the y's. Do the math. So notice my coordinate is 1/2 and -1/2, and if that's 1 there, there's 1/2, and then down 1/2, and boom, there's my midpoint. Check. Let's do this one down here. Add the x's, divide by 2, add the y's, divide by 2. So that's 2 and 3. Whoop, -2, that photocopied, and +3. That's a -3 and +2. Got it. You do your math and you end up with +1/2 and -1/2. Once again, +1/2, -1/2. So that means that we have the same midpoint going both directions, which implies that this diagonal cuts this diagonal in half and this diagonal cuts this in half. In other words, they bisect each other. Math, meaning, punchline. Here's the math. Okay, there's your math. Meaning, both segments share, got to do the light dance, share the same midpoint. Punchline. Therefore, they bisect each other. Math, meaning, punchline.